Okay, so now finally we're going to finish this up. We're going to talk about how we can convert or change between molarity, if we know it, moles, volume in liters, and even mass. So if we know one thing, we can convert and find out information about the other measurements. Now we're going to consider how many grams of sodium sulfate are required to make 0.350 liters of a half molar solution of sodium sulfate. So we're going to have just going to draw my flask. I'm going to have a flask that is 0.350 liters, and the molarity will be 0.500 molarity of sodium sulfate. I always like to draw pictures so I can see what I'm doing. And I'm looking for how many grams I need. That's what I want to find out. So I write that down. Now, what information do I have to start with? Well, I know I have 0.350 liters, 0.500 molar. This is all of a sodium sulfate solution. My formula for molarity is moles over volume in liters. Here I have my volume, here I have my molarity, so I just have to find my moles. If I can find out how many moles I need, then I can use the molar mass to convert that to the grams. So anytime you have molarity, you're probably going to use your molarity formula. So let's solve now for this moles, which is pretty easy. If we want to leave, we're going to multiply both sides by 0.350, and we end up with, and our molar mass of sodium sulfate is 142.1 grams. So I'm going to, in grams, I will have 24.8675, which I will round. I'm going to round to 3 significant figures because that's how many I have in all these numbers. So that would be 24.9 grams of sodium sulfate is what I would need to make this. And I just realized I didn't even put this problem on your notes, but now you know how to do it anyway. So we talked earlier in these notes about how to make a solution. We learned how to do that by adding, and that we talked about how we would mass out the solute, put it into the flask, and add water. But now we're going to learn how to make a solution by dilution. And that means, let's make this picture bigger, that we'll have a solution that's concentrated, and we'll take a little bit of it out and put it in another flask, and then we'll add water until we get to a new volume, and this second solution will be less concentrated, but it will be of a specific concentration. We can take some of the concentrated out, put it in here, add water, and we make a less concentrated solution. So that's what we're going to do in the next problem. And I hope this one's on your paper. Yes, how many milliliters of 3 molar are needed to make 450 milliliters of 0.1 H2SO4. So if you stop and look, we're starting with the 3 molar H2SO4, and we're making something like that. So we have a solution that is very concentrated, and we have a lot of it, a lot, and we're going to make over here 450 milliliters of a solution that's only, this one was 3.0 molar, this one's going to be only 0.1 molar, so much less concentrated. It's meant to look lighter. So how are we going to do this? Well, we need to figure out how many moles we need in here. We need to figure out how many moles we need in this 450 milliliters to make a 0.1 molar solution. Let me write that down. This is 0.1 molar, so we know that molarity equals moles over volume in liters. So here we have 0.1 molar, and we know it's going to be 450 milliliters, which is 0.450 liters. Sidestep, 450 milliliters times your conversion factor. There are 1,000 milliliters in 1 liter. Gives you 0.450 liters. So back over here, I have molarity equals moles over liters. Moles. Where are my moles? I don't know. I don't know how many moles I have in here. But if I could find out how many moles I have in here, then I could just take those moles out of here and put them in here and add water. So that's what I'm going to do. First, I need to find out how many moles do I need here. So let's do that. Multiply both sides by 0.450, and we find that the moles that we need are equal to 0.1 molar times 0.450 liters, which equals 0.045 moles. So that is how many moles of sulfuric acid I need to put in here. Well, where am I going to get those moles? I'm going to get them from here. How am I going to know how many to take out? This is a liquid. This is a solution. Well, I need to find out the volume. What volume? I'm coloring a smaller section of volume. What volume would hold over here only 0.450 moles? If I can find what volume holds this many moles, I'll just measure out that volume with a pipette and then squirt it in here. So we're going to do that. From this solution now, we need to find out what volume holds 0.450 moles. And we have a relationship between moles, volumes, and molarity. Chemistry is all about relationships. It's like a giant dating game. So here we have 0.045. Oops, I'm going to run out of room. Let's just see if we can erase that. Yeah, do it in red. So we're going to have 0.045 moles over an unknown volume. So our volume here is X, because I don't know what this volume is that holds this many moles. But I do know that the molarity over here is 3 molar. So I'm going to write that here. So now I can solve for this variable that's in the denominator. It's not always fun to solve for things in the denominator, but you can. First I'm going to multiply both sides. By X, so I get X out of the denominator. And then I'm going to divide both sides by 3.0 molar. I'm just going to show you how I do that. Okay, so I got X out of the denominator, because you don't like variables in your denominator, by multiplying both sides by X. Now I'm going to divide both sides by 3.0 molar. This is just math. This cancels on this side, and I end up with X liters, or X, we'll just call it X, equals 0.045 moles over 3.0 big M, and I can rewrite this big M as moles over liters, which is nicer because it shows us that our moles are going to cancel here. And and units are very important, which you may be finding out, hopefully you will. When you have a fraction in your denominator of your original fraction, whatever is in the denominator of that original fraction is actually in the numerator. So our units are going to be liters. And our number is going to be 0.045 divided by 3, which is, I'm going to write it up here, 0.015 liters. So that is the volume that I have to take out of this flask with a pipette. My pipette. I have to pipette it out. Then I'm going to take the pipette over here and squeeze in that, and then I will add liquid. You're going to do this tomorrow, hopefully. And did we answer the question? How many milliliters? Well, this was in liters, 0.015 liters, 0.015 liters. This is a 0. And we want to convert it to milliliters. 1 liter, 1,000 milliliters. It's going to equal 15 milliliters. So you always want to go back and make sure you answer your question.